Hello and welcome. This is going to be our lecture video for September 23rd through 24th. We're going to be starting a new unit today all about systems of equations. All right, here's a warm-up problem for you. Can you figure out, just try to reason your way through it, maybe not even try to use any equations, just reason your way through what the values for square, circle, and star are. Okay, I'll embed a question here. All right, the correct answers are square is equal to 2, circle is equal to 3, and star is equal to 6. We can make sure that that works. So 3 plus 3 equals 6. Yep, that checks out. 3 times 2 equals 6. Yep, and 6 is equal to 2 plus 2 plus 2. All right, so there's a lot of different ways to reason through this, but by the end we're going to figure out how to do this algebraically. Our goal for today is to begin our next unit on systems of equations, and today is going to be all about developing sort of a general understanding of what is meant by systems of equations. Okay, so I want you to take notes on the important values from this word problem here. So imagine this race. Abraham Lincoln and Usain Bolt are going to race. To make the race fair, Usain Bolt is going to start 40 meters behind the start line, and Lincoln's going to start 20 meters ahead of the start line. Bolt can run 10 meters per second, and Lincoln run 7.2 meters per second. Who would win in the 100 meters? So not who would run 100 meters first, but who's going to cross the 100 meter mark on the track first, because they're starting at different points. Lincoln's going to have a shorter distance to run, Bolt's going to have a longer distance to run. And then who would cross the 200 meter mark first? And then when and where would Usain pass Lincoln? Okay, so your goal is to write down all of the important information from this problem and organize it in a way that makes sense to you. All right, one way that makes sense to me to organize this would be into equations. An equation for Usain's position and an equation for Lincoln's position. Now I'm going to use x to represent seconds since the start of the race, and that's going to be the same for both of them. I'm going to use y to represent the distance m from the start line, but that's going to be different for them. So I use a y sub u and a y sub l to differentiate these. All right, now the speed that they're running at, that could be thought of as the slope, because that's what's going to change their distance relative to time. And then where they start, that could be kind of like a y-intercept, because that's not going to change. But we also sometimes call the y-intercept the starting value, so that makes sense to me why that would be right there. All right, another way that makes sense to me to organize this information would be in a table, and with a table we can start answering some of those questions. So what I'm doing to create this table is I'm plugging in different x values for seconds and then recording the different y values. So this is y sub u, this is y sub l. All right. I've also highlighted who is further down the track at different times. And you can see Lincoln, he starts further down the track as he starts at 20, and he stays further down the track until some point between 20 and 25 seconds he is passed. So we can answer the question about who won the 100 meter here. It's got to be Lincoln, because he was still ahead all the way up to 164 meters. Now this also really makes it look like Usain Bolt won the 200 meters, because right as Lincoln passes the 200 meter mark, Usain's already at 210. Another way I could look at this would be with a graph. This graph is going to show their relative positions on the track over time, and the graph is really useful because we can see where they are at the same point on the track at the same time. So this is where Usain passes Lincoln. All right, I'm gonna pause the video here to try to get my dog to stop making so much noise. All right, I'm back. Okay, so we've looked at how we can represent a system of equations with equations, tables, and graphs. Now to answer our final questions, who won the 100 meters? Well, we saw in the table, it looked like it was going to be Lincoln, and we could have solved for exactly when he won the race by plugging in a 100 for his y value and solving for x. He started, I think 20 meters down the track. And if we solve this, we get 11.1. Who won the 200 meters? It was Usain Bolt with the time of 24 seconds. This one we plug in 200 for his y value. And then solve for x. And then when and where did Usain pass Lincoln? What we're doing is we're setting these two sides equal to one another. That will solve for the x value. Then you can plug it back into either of their equations in the position of x, and then that's going to give you 174.3 meters. Okay. So when we say we're going to solve a system of equation by graphing, what we're going to do is we're going to graph both lines on the same coordinate plane, and then we're going to see where they cross. So here I've got two equations. I'm going to link them into a system with a curly bracket like this, and I'm going to graph them both in the same coordinate plane. So for that top equation, it's got a y-intercept of 2 and a slope of 1, so that means go up 1, right 1, up 1, right 1, up 1, right 1, all the way across the graph, and then we can reverse that. So what you can think that we're doing is we are representing all of the ordered pairs that make that first equation true. Here are all of the ordered pairs that make that first equation true. All right, now let's represent all the ordered pairs that make that second equation true. It starts with the y-intercept of -4, and then it has a slope of 4, so up 4 over 1, up 4 over 1. There we can see they cross. I'm going to connect these up with a line. Alright, if the red line is all of the ordered pairs that make the first one true, and the green line is all of the ordered pairs that make the second one true, there's only one ordered pair on the entire plane that makes them both true at the same time. And that is the point 2, 4. And we can leave our answer like this, or we can explicitly say x equals 2 and y equals 4. And then put a box around that. And that's how we solve a system of equations by graphing. All right. I want to teach you how to do this on your calculator now. So if you've got a TI calculator, get it out. What we're going to do is we're going to graph these equations using the y equals button, and then we're going to figure out where they cross. Okay. So press y equals, make sure any equations in there are cleared out. And now let's look at the equations that we have. We have let me try to give this maximum screen size possible here. So this is already at the y equals on that side. If our equation isn't in y equals form, we have to change it around until it is in y equals form. And now 2/3 x, I'm going to keep the 2/3 in a set of parentheses. For x, I'm going to use this button right here. That's our variable button. Plus 7. All right. For the next one, we've got negative x minus 3. When I do the first negative, you have to use this button here. If you use just a minus at the front, it won't work. It'll give you an error message. So now I've got negative x minus 3. And now I want just kind of, I don't know where these are crossing. So a good window to start with is to press zoom and then number 6 to get kind of a standard viewing window. And the dimensions of this is going to be -10 to 10 in both directions. And we can see where they cross pretty clearly here, but we don't know its exact value. So that's why we can press look here, it's second trace intersect. So the second button, you press trace, which really accesses the calc menu, and then intersect is number 5, so I can just press 5. Now you just read these questions. First, curve. It calls all lines curves. So even though it's a straight line, it says which is your first line or curve. We'll just press enter. We'll press enter again for the second one. There's only 2 lines there. If there was multiple lines, it would need to know which 2 it's trying to find. And then it says take a guess. This isn't super necessary. I can move my cursor over closer to this intersection point. But the guess only matters really if there's 2 intersection points, because it'll give you the one closer to your guess. And there it's calculated for us. X equals -6, y equals 3. So x equals -6, y equals 3. All right, here's 2 more. You can either practice on graph paper or with a calculator. I'll pause the video for you to do that. And the correct answers were -4, -5, and -1, 8. Well, this says with a partner, that's old. By yourself. Does every system with 2 variables have only one solution? What do you think about that? I'll have you type your answer here. How is it possible to have no solution? So the correct answer to number 1 is that no, it is possible to have no solution. Now I want you to tell me how that is possible. And number 3, what scenario would result in a system with infinitely many solutions? So this is another possibility. Instead of one solution, we could have infinitely many solutions. Can you describe that scenario? Okay, and here are those 3 scenarios in different graphs. Which one is which? 0, 1, or infinite? Well, they are lined up right now. Our first graph would have 0 solutions, where we have 2 parallel lines. The second graph would have 1 solution because they have a spot where they intersect. And for the infinite, we can't even see the second line because it's right on top of that first line. So it's right under there. And if they are the same line, we can say they're coincident lines. They have infinite solutions. So it's the number of places they cross. Okay. I'll embed a few more questions here, but that's that for this video. Have a good rest of your day.